Hello guys, in this video we will discuss about the cross product of vectors. In our previous lecture we have discussed about the dot product of vectors, and we see that the dot product of vectors leads to a scalar quantity. But here we will define vector multiplication, which will give us a vector, but this product is defined only for 3 space, or sometimes we call it as the R3. That means the cross product of vectors is defined only for R3. So let us start with the definition of cross product of vectors. Suppose we have two vectors u and v in R3. So the components of u are u1, u2, u3, and components of v. So cross product of two vectors u cross v is defined as, just write down as the first row I, j and k. These are the unit vectors I, j and k. And in the second row, write down the components of u, u1, u2, u3. In the third row, write down the components of the vector v. So the determinant of this will gives you the vector. Suppose it is a1i, a2j, a3k. So this will be the cross product of vectors, and you know that if you have any vector in R3, so either you can write it down as in the linear combination form of standard unit vectors as a1i plus a2j plus a3k, or so these two numbers or the components, they are equivalent representation of the vectors. We have discussed already this thing, and if you want to know how, you can check this video. So there is also another way to write down this vector component of the cross product of vectors u cross v. Let me show you. You have vector components u1, u2, u3, v1, v2, v3. You have, this is for vector u, this is for vector v. The cross product, you can write it down. For the first component, hide first column and write down the remaining 2 by 2 determinant, which is u2, u3, v2, v3. For the second component, first put minus sign, hide second column or the second components of u and v, and write down remaining 2 by 2 matrix, which is u1, u3, v1, v3. Third component of the vector u cross v, hide third column and write down the remaining 2 by, find the determinant of the remaining 2 by 2 matrix, which is u1, u2. So in this way you can also get the cross product of two vectors. One more thing, this cross product of vectors, it is orthogonal to its component vectors. What does it mean? It means that if suppose this is your W, cross product of vectors, then this W is orthogonal to U and this W is orthogonal to V. Orthogonal to U means their dot product will be 0 with its component vectors U and V. Now let us see an example for the cross product of vectors. Suppose we have to find the cross product of vectors u cross v. So just write down the vectors, components of u, 3, 1, 4, minus 1, 0, 1. So for the first component, hide first column and write down the remaining 2 by 2, 1, 4, 0, 1, comma, put minus sign. For the second component, hide second column, 3, 4, minus 1, 1, 3, 4, minus 1, 1. And for the third component, hide third column and write down the remaining 2 by 2 matrix, which is 3, 1, minus 1, 0, 3, 1, minus 1, 0. Now just find the determinant of a 2 by 2 matrix. You know that if you have 2 by 2 matrix A, B, C, D, so its determinant is given by AD minus AC. This is just for recalling you. So it will be 1 minus 7, 1 is the required cross product of vectors. So in this way we can find out very easily, or if you want to find out by the method of determinant, so what you do, just form 3 by 3 determinant of I, j and k, write down the vectors 3, 1, 4, minus 1, 0, 1. Now just find the determinant of this, and you will get the vector as I minus 7j plus k, and you know that these two have same meaning, so you will get the same vector. So if you want to find out the cross product of vectors using determinant of a 3 by 3, so you can use this method. Now we have another example. Suppose we have to find a unit vector which is orthogonal to the vectors this and this vector. Because we have to find a unit vector which is orthogonal to the vectors. Orthogonal means the vector, this vector must be perpendicular to u and v, and we know that the cross product of vectors is orthogonal to u and orthogonal to v. So it means first we have to find the cross product of vectors, and then we will normalize it. We have already discussed how to do the normalization of a vector. So first find out the cross product u cross v, which is given by, write down the components of u, 3, 2, 1, minus 1, 2, minus 3. So for the first component of u, hide first column and find the determinant of the remaining 2 by 2 matrix 2, 1, 2, minus 3, minus. For the second component, hide second column, write down the remaining 2 by 2 3, 1, minus 1, minus 3. For the third component, hide third column and write down the remaining 1, 2 by 2. Now simplify these components, you will get minus 8, minus 8, 8. So this is your cross product of vectors u cross v, and this vector is orthogonal to u and v. Now just we have to make it a unit vector. That means we have to do the normalization of this vector. We say that suppose this is equal to the vector w. So first find out the norm of the vector w, because we have to do the normalization. So for the normalization, first we will find out its length. So it is component square minus 8 square minus 8 square and 8 square. Simplify it, you will get. So for the normalization of the vector, say this is vector t which is defined by, so we have to use this formula. This is the normalization formula. So this is equal to 1 upon under root 192, or you can write down t as, so this vector t is the unit vector which is perpendicular to this and this. You can check it. Okay. Now let me give you the example of standard unit vectors of R3. So the standard unit vectors for R3, we know that it is given by, so if you check out the cross product of vectors of I cross j, it will be again just form 1 0 0 0 1 0. This is vector I and j. For the first component, hide the first column, you will get 0 0 1 0. For the second component, put minus sign, hide second column 1 0 0 0. And for the third component, hide third row, you will get 1 0 0 1. Now simplify it, you will get
0 0 1, which is equal to k. So the cross product of I cross j comes out to be k. Similarly, if you do the cross product of j cross k, then you will get I, and if you do the cross product of k with I, you will get j. Now let us explore what will comes out to be the cross product when we take I with I. So so the cross product of I cross I will comes out to be 0. Why? Because if you find its value by the method of determinant, in the first we will write down the unit vectors I, j and k, and write down second and third column as I, and we know that the value of the determinant is 0 when we have two identical rows. So the value of cross product I cross I, it will be 0. Similarly, we can find that j cross j is 0 and k cross k, it will be 0. So let us see the other possibility of cross product of the standard unit vectors. That means if we take j cross I, it will comes out to be minus k. If we find out k cross j, it will comes out to be minus I, and I cross k, it will comes out to be minus j. So this is the all the possibilities of cross product of the standard unit vectors. Now to understand this, we can make a circle and just write down these standard unit vectors in clockwise direction. Make it I, j and k. So for seeing that the cross product of the vector with itself, it will comes out to be 0. We have already seen it here. For I cross j, so just take it clockwise, take any two consecutive vectors, you will get the third one if you are going in the clockwise direction. That means if you take I cross j, so it will comes out to be k. If you take j cross k, it will comes out to be I, and if you take k cross I, it will comes out to be G. But if you are going in anti-clockwise direction, then you will get J cross I, it will be minus K. If you go K cross J, it will be minus I, and if you go J cross I, it will be minus K. So in this way you can remember the operations of cross product on the standard unit vectors on R3. Now let us discuss the properties of cross product. So the first property is that the cross product of u cross v is same as minus times v cross u. That means cross product is not commutative. That means the values of u cross v and v cross u, it will not be same. There will be a difference of minus sign. The second property is that the cross product is distributive over addition. That means the value of u cross v plus w will be same as u cross v plus u cross w. The third property is that the addition of vectors is distributive over cross product. It means the value of u plus v cross w is same as u cross w plus v cross w. And the fourth property is that the cross product with the vector itself, it will comes out to be 0. We have already seen it before. And the fifth property is that the cross product of any vector with a 0 vector will gives you a 0, and it will be same as 0 cross u. So these are some properties of a cross product which can be easily verified by taking any three vectors from R3. So I hope that this will be a very good exercise for you to check these properties, and it will be a good work. Now let us discuss the difference between dot product and cross product. So as we have already discussed about the dot product, so first difference is that the dot product of two vectors is comes out to be a scalar. That means when you take any two vectors and you take dot product, you will get a scalar number. But in cross product, if you take any two vectors, so their cross product will comes out to be a vector. The second difference is that the dot product is valid for any vector space. That means if you take either Rn, that, or if you take the vector space of square matrices such of order n, or in general any vector space of matrices of order m cross n, or even if you take the vector space of polynomials of degree less than equal to n, the dot product will work on these vectors. But in cross product, it is valid only for R3 or say 3 space. The third difference between a dot product and a cross product is that the dot product is commutative. That means if you take any two vectors u and v and you take dot product u dot v, it will comes out to be same as v dot u. But cross product is not commutative. That means if you find out the cross product u cross v, it will not be same as v cross u. That means cross product is not commutative. The fourth difference between dot product and cross product is that if you take a dot product with the vector itself, either it will gives you a positive quantity, or at least it will gives you 0 if the vector itself is a 0 vector. But the cross product of the vector with itself will always gives you a 0 vector. So these are the difference between dot product and cross product. So I hope that you enjoy these differences, and overall if you like this video, so please share it and subscribe to my channel. Thank you so much.